The D11. This sophisticated dozer is a true piece of engineering wonder, proudly exhibiting features from its ancestors, plus the cutting-edge technology of today. From the back ripper to the front bucket, the D11 is 34 feet 6 inches long, 11 feet 10 inches wide, and 15 feet 6 inches high, weighing more than twice an M1 Abrams tank. It's the third largest and most efficient dozer in the world. It was the era of a whole new revolution. Mankind had learned to use steam power and fuel combustion. Farmers were using tractors to plow land, but California's soggy peat soil made it nothing short of difficult. One man named Benjamin Holt decided to do something different, becoming the co-founder of today's Caterpillar. At that time, the railroad system was at its peak. Industries like mining, construction, and transportation relied on railway networks. Holt knew his company wouldn't grow if their tractor remained under the mercy of soil conditions. He first experimented with wider wheels, even trying 18-foot wide wheels. But that made him realize how the size of machines affects their efficiency, cost, and usability. He then spent years developing a whole new alternative to wheels, which could enable his massive tractors to navigate across all terrain types. In 1914, on Thanksgiving Day, Holt instructed his mechanics to remove the rear wheels from the 40-horsepower Holt Jr. steam traction engine and replace them with a pair of tracks he had designed. His devised tracks were 9 feet long and 24 inches wide. Each track shoe consisted of 3x4-inch wooden slats bolted to an endless chain. It shifted the weight of the machine on rollers anchored to a supplementary frame. This new patent by Holt was a commercial success, opening new avenues for the tractor's usability.
West Aurora Street in Stockton, California, that Benjamin Holt perfected the track-type tractor in 1904.
The Cat D11 is equipped with a similar but more sophisticated track technology. It has an elevated sprocket undercarriage, also known as HXDL. This heavy-duty undercarriage is specifically designed to reduce scalloping in high abrasion conditions. The main part of the tracked undercarriage is its metallic chains, which consist of crowned rail links. These rail links are interlocked with each other by bush locks. The front and back idlers and the bottom rollers serve just to rotate it smoothly, while the upper sprocket takes power from the main drive to push the whole chain. The credit for the crawling undercarriage goes to Benjamin Holt, but he's not what made these tractors into dozers. The dirt-pushing blade is registered as a patent in the names of a farmer and a draftsman. In 1923, James Cummings and J. Earl McLeod collaborated to design a blade that could be attached to the front end of Holt's tractors. After 2 years, their invention was accepted as a patent. The same year, Holt Manufacturing Company and CL Best Tractor Company merged into one entity, Caterpillar Tractor Company. Tractors of this decade can be seen in black and white pictures, boasting a large, thick metal plate in the front. 3 different types of blades have become common in use. This includes the S-blade, the U-blade, and the SU-blade. The S-blade is the simplest blade. It is usually short and has no lateral curves or side wings. It is best suited for fine grading, ditching, and stripping jobs. The U-blade is also known as the universal blade. It features large side wings to carry more material. The U-blade is also the largest blade type in both height and width, and is best used with soft to medium density soil. Some of the best tasks for U-blades include ditching, hauling, pushing, and crowning. The SU blade combines the features of both the S blade and the U blade to provide more substantial penetration and better overall versatility. It's less curved, and its side wings are smaller than a normal U blade. It's used to push soft to medium density sand and soil over long distances. Crowning, moving heavy material, stumping, and ditching are some of the best uses for an SU blade. Many suppliers were offering special blades designed for Caterpillar track tractors. But in early 1945, the company decided to develop its own line of dozer blades. Decades of dozer research and development have made Caterpillar the leader in blade technology. Caterpillar now manufactures a wide range of blades for its machines that perfectly meet quality standards. However, aiming for excellence is one thing, but striving to push your own boundaries is quite another. The well-engineered design of the D11 was an example of such a push. The latest generation of this dozer has a 29.3-degree interior angle between the rear bottom of the blade and the ground. This clearance angle further improves the blade's ability to grade and load. The D11 can be outfitted with a large variety of different blades, such as a 35.6 cubic yard SU blade or a 57 cubic yard U blade. Competition produces the best products, especially when rivals are equally capable. The closest competitor of the CAT D11 is the Komatsu D475, which is the largest dozer in the world. It is 38 feet 9 inches long, 20 feet 4 inches wide, and 15 feet 5 inches tall, bigger in every dimension than the D11. But in terms of performance, both dozing titans stand side by side. As a matter of fact, the CAT D11 can hold a bigger blade, albeit by not that much, and consumes less fuel. Because of Caterpillar's long history, the D11 has many advantages over other competitors. Technologically, it's still considered ahead of other dozers. The backbone of any dozer is its robust frame. In the case of the D11, the main frame is made by casting high-strength steel. It supports the whole structure and absorbs high-impact shock loads and twisting forces during service. The main structural skeleton is formed through the welding of steel plates. Caterpillar uses welding robots equipped with vision technology to ensure an accurate measure of the performed welds, while skilled workers perform prep and tack welds. To create their iconic yellow coats, Caterpillar uses electrostatic painting systems that work autonomously. Next, the transmission and the engine are mounted on the frame. After assembling the hydraulic cylinder and blades, the cab is installed. Once all is done, electrical lines and fluid lines are attached to fitted connections. In October of 2018, Caterpillar celebrated the manufacture of their 40,000th CAT large dozer. All heavy-duty dozers come standard with dual tilt technology. It allows the operator to pitch the blade forward or backward, depending on what stage of the cycle they are in. This also increases the operator's workload, as they have to precisely tilt down the blade for cutting, raise it back up when not, and roll forward for it to spread. To make this task less tiring, Caterpillar included the Automated Blade Assist. The Automated Blade Assist is also available for the D11. It lets the operator preset the tilting level of the blade. With just the push of a button, they can angle the blade for cutting, moving, or spreading from anywhere. In this way, they don't have to use their arms repeatedly for each pass. Caterpillar also offers an optional 3D grade control system for the D11, which makes the operator's job almost automatic, as well as elevates the grading operation to the next level. The grade control system is based on twin GNSS antennas and an array of inertial measurement unit or IMI sensors. This cutting-edge technology automatically measures the conditions and precisely adjusts the blade motions, including lift and tilt. For dealing with tons of soil materials, a dozer needs a powerful engine that can provide high torque throughout all daily duty cycles. This problem can be solved by simply using any high horsepower engine, such as the Cat 32. It's the most power-dense, high-speed diesel engine ever, providing more than 840 horsepower and a peak torque of 4,548 pound-feet. But an increase in horsepower means more fuel consumption, which is one of the most important aspects to consider for working costs. It also does not solve the lagging that occurs when a dozer utilizes more or less energy than needed for the load. To cope with such issues, Caterpillar smartly devised a whole new electric powertrain for all of their flagship dozers. The XE version of the D11 is the most fuel-efficient dozer on the market. Its powerful diesel engine is connected to a generator, which converts the mechanical output into electrical energy. A control unit transmits the required energy to all derived terrain motors. Subsequently, the engine does not have to change revs nearly as much, with the excessive power, if generated, stored for later use. It also solves the lagging problem, since the electric motors are many times more responsive than a mechanical gearbox-based drivetrain. This also ensures exceptional maneuverability with zero gear shift, less downtime, and longer rebuild lifespan. Ultimately, what this means is that Caterpillar has tried to create a powertrain that optimizes power to the ground with durability and ease of service to deliver a low cost per ton in dozing applications. As the saying goes, with great power comes great responsibility. In this case, a responsibility to keep the operator safe, which is why it comes packed with plenty of safety features. In the event of emergencies, its engine shuts off automatically, and the factory-installed fire suppression system activates instantly to extinguish fires within seconds. Guardrails, sensors, and cameras are all around the machine. Its power ladder is stored in sections when not in use. Thanks to large windows, mirrors, and display screens, the operator always has a 360-degree view of his or her surroundings. The D11 senses whether the operator is on the seat or not, and it automatically locks the powertrain to prevent unintentional movement when the driver leaves the seat. The Cat MineStar is a new object detection system. It adds radar capabilities to boost awareness of what's happening around the machine. This technology can automatically identify objects and alert the operator for potential hazards, regardless of whether the danger is in front, behind, or within the turning radius on each side of the machine. It also highlights specific views to show operators where potential hazards may be located. Improving something that is already ahead of its time is certainly a difficult task. Caterpillar needed to collect a team with a strong passion, foresight, and commitment. Enhancing productivity is always important, but there is a requirement, more than ever, to ensure safety for the operators and to maximize efficiency. One such example is the recent development of a remote operator station that is able to control the machine wirelessly. Wolf Group is the first company in Australia to use this technology. They have thus far deployed 6 D11 dozers to work remotely at a mining site, producing consistent quality results and removing the chance of operators being injured in an accident. At the same time, this is an alien experience for operators, something entirely new. Now, instead of sitting inside the cab, they operate the machine remotely. They do not experience vibrations and noise in the same way anymore. But it seems, according to what we've seen so far, that they do not get tired as quickly, reducing operator fatigue. Along with remote control, D11 dozers are now available with semi-autonomous operation. It enables a single operator to operate up to 4 machines in push-to-an-edge applications, maximizing dozing efficiency while site operational expenses are reduced. This system responds to mapping environmental changes in real time and is intended to handle operator interventions fast and seamlessly. In the future, Caterpillar wants to make this beast of a machine fully autonomous. The D11 is most typically used in large-scale forestry, mining, and quarrying operations. Because of this, it is always going to be a challenge to get it from the point of manufacture to its final destination, which is usually going to be in a remote location. The D11 is not a Mini Cooper, and the process of getting it anywhere is complex. At the very least, it is partially dismantled before being sent to most locations. In the United States, some are carried by flat car trains, without the blade, push arms, or ripper frame. Others are disassembled into many parts, making it easier to put into a number of different trailers for transport. From the mining sites of Australia to construction projects in Europe to the farmlands of the USA where its whole story began, the D11 can be found anywhere in the world dozing Earth with elegance. After all, it's the uncrowned king of its class.